invisible sheep. Welcome back to our classroom. Today, I'll be teaching you about areas. The formula for the area of triangles is the base times vertical height over 2. The area of the purple triangle is made up of D plus C. Considering the vertical height and the rectangle of the base, we can see that the area of the triangle we are looking for is half the area of the rectangle. Therefore, the area of the triangle is half of the area of the rectangle. And if you don't know, which you literally should, the area of a rectangle is the vertical height times base. And since the area of a triangle is half the area of the rectangle, it's vertical height times base divided by 2. Now I'll teach you about the area of the parallelogram. The parallelogram is base times vertical height. The area of a parallelogram is the base times the perpendicular height. This can be understood by moving triangle E to the location of triangle E comma. Because if you put a line through the area of a parallelogram is the same as the area of a rectangle made by its base and perpendicular height. Because if you imagine this is a piece of cake, and then when you cut the normal E off and then you move it to the E apostrophe spot, then it's a rectangle. But it's just that is in the wrong place, and the area doesn't change just because it's in a slightly different shape. So the area of a parallelogram and a rectangle has the same formula, just in a different way of saying it. The area of a trapezium is the top plus the bottom times vertical height over 2. First, take 2 trapeziums, flip one upside down, and then stick the 2 together. A parallelogram appears with a base that is the same length as the top. A parallelogram appears with a base that is the same length as the top side and the bottom side added together of the trapezoids that you added together, of a singular one. The area of a trapezoid is half the area of this parallelogram, so the area of the trapezoid can be calculated as the top plus bottom, the lengths times the vertical height divided by 2. You have to add the top and bottom first. Don't multiply the bottom times the vertical height. No, there's brackets around the top plus bottom. Now I'll tell you about the area of a circle. It's pi r squared, or pi times radius squared. If you divide a circle into n sectors, each sector has a base that is 1 out of n of the circumference and height of a radius. If you rearrange these, they approximate a rectangle whose base is half the circumference, or pi r, and whose height is r. The area of this rectangle is pi r times r, which is pi r squared. The smaller you make the sectors, the more accurate this approximation becomes. So the more n you have, the smaller the sectors. And the smaller the sectors, the more accurate this approximation becomes. Now I'll teach you about how to calculate the area of a sector. It's y over 360 times pi times radius squared. To find the area of the orange part of the circle below, we need to find the area of a sector with a central angle of 90 degrees. In other words, we need to find the part of the circle with a central angle of 90 out of a central angle of 360 degrees. So we multiply the area of the circle, pi r squared, by 90 over 360. Or in other words, multiply that by a fourth to find the area of the orange part. To be clear, 90 degrees is just an example. 90 degrees is the y in this equation, in this formula. Now I'll tell you how to calculate the area of a segment. How do you find the part that is shaded red? Simply subtract the area of the triangle from the sector. In this case, the area of a sector is y over 360 times pi r squared. We use sine to find the area of a triangle. The area of a triangle is r squared times sine y over 2. Therefore, the area of the red part can be found as y over 360 times pi r squared minus r squared times sine y over 2. Now, I'll give you a few questions to test how well you understood and listened to me. Number 1. There is a trapezoid ABCD as shown in the figure to the left. Moving point P moves from A to D, and moving point Q moves from C to B at 1 centimeter per second and 2 centimeters per second respectively, in that order. After how many seconds will the area of the quadrilateral ABQP become half that of the trapezoid ABCD? The upper base of the trapezoid ABCD is 8 centimeters and the lower base is 20 centimeters, so 8 plus 20 is 28 centimeters. In other words, find that when the upper base plus the lower base of the quadrilateral ABQP is 14 centimeters. Initially, the upper base equals 0 centimeters and the lower base is 20 centimeters, so the upper base plus lower base is just 20 centimeters. Every second, P lengthens the upper base by 1 centimeter and Q shortens the lower base by 2 centimeters. Basically, every second, the upper base plus lower base becomes smaller by 1 centimeter. Therefore, if the initial upper base plus the lower base is 20 centimeters, it will become 14 centimeters. When it has become shorter by 6 centimeters, it will be after 6 seconds. Number 2. Find the area of the sector shaded in the color orange. The answer is, the area of the sector is pi times 6 times 6 times 60 over 360, which is 6 pi. The area of the triangle is 6 times 6 times sine 60 degrees over 2, which is 1 over 2 times 6 times root 3 over 2. Therefore, the desired area of the orange part is 6 pi minus 9 root 3, which equals 3.25 centimeters squared. And that is it for today's video. Please like and subscribe if you learned something new. 3, 2, 1.